I first position myself to record the forearm, which is there, and then I position myself for the gait cycle, and I record the values here. These are the values I got for the forearm. As you can see, the X values for acceleration are pretty similar as time goes. That's because there is not much change in the Z axis since the forearm moves up pretty much along the X and Y axes. The same for the tilt angle. The tilt angle pretty much remains the same throughout. You can see that at some point the tilt angle and the acceleration increase. That is when the forearm goes from the mean position to the extreme position. For it's the same thing for the gait. The gait cycle, the acceleration changes are mostly in the X and Y axes. The tilt angle changes in about X and Y at the same time. The reason why Y is negative and X is positive is just because of the orientation of the microcontroller. So it goes from 0 to 180, and the bottom, like if you go all the way to 360, would be again 0 to 180 but negative. The reason why Z is pretty consistent for both forearm and gait is because the Z axis is through the board, and so because there's nothing moving along that plane, the values are pretty similar. The reason why it's not exactly the same because there might be some small changes in the Z axis when you're moving. It's not perfect. This is the data that I took for when there is quick movement in the forearm. The first graph shows the original data. The second graph, which is labeled acceleration 2, is for when their forearm is moving quickly from mean position to extreme position. As you can see in the first graph, the original graph, the acceleration is more gradual, and in the second graph, the y-axis, or the acceleration on the y-axis is very sharp. Same kind of, you can see it for the x-axis. I believe that the y-axis is the acceleration on the y-axis is much more than the acceleration for the x-axis is because the y-axis is vertical to the arm, whereas the x-axis is along horizontal to the arm. And so I would believe that most of the acceleration is along the y-axis. I also noticed that towards the end, the acceleration in the x-axis starts to increase, and then the y-axis it starts to decrease. And that's because as the arm is moving up, the acceleration is mostly in the y-axis, and then once it gets towards the top, the acceleration is moving mostly on the x-axis. And I believe that towards the end, why it starts going up more, where the slope gets steeper, maybe because from the arm moving so quickly from mean to extreme, that the arm moved back, the whole arm like moves back a little bit. So I thought that was interesting.